So today we're going to start learning about the basics of radians. So the first question you might have is, what even is a radian? So here's how we think of what a radian is. It is a way to measure angles, just like degrees. So before we get started on taking notes on the notes packet, I want you to maybe write this down on a separate piece of paper or maybe right before the notes. So just like I might tell you to rotate your eyes 90 degrees and look to the right, I could tell you to rotate your eyes a certain number of radians, and that would be the same thing. I'd be asking you to spin or to move some angle. So if we think of a circle, this circle has a radius. If I take this radius and kind of lay it along on the circle so that this orange length is the same length as the radius. So let me say that again. So that means the arc length, that orange line, is equal to the radius. And I make this into an angle. This angle that it's formed, where the radius is equal to the arc length, is 1 radian. So a single radian is equal to about 57.29 degrees. And this is just another way that we've decided to measure circles or measure angles. So if you have something in degrees and you want to convert it to radians, you take the number of degrees you have and you can convert it by multiplying by pi over 180 degrees, and you end up with the number of radians. If instead you had a certain number of radians and you wanted to know how many degrees that was, you'd multiply by the opposite. So you'd multiply by 180 degrees over pi. So we get some really cool features from radians. So if we have a basic circle like this, and here's our center and here's our radius. Well, 0 radians is the same as 0 degrees. And then 180 degrees is the same as pi radians. And then 360 degrees all the way around is the same as 2 pi. So instead of saying I spun 360, I spun all the way around, you could say you spun 2 pi radians. So that's where this little conversion comes from, because you know pi is equal to 180 degrees. So the first thing we're going to do is fill out the table just like we did for degrees. So you'll notice a lot of these notes are really similar, but now we're working with radians. And one hint usually when you're working with radians is that it has some pi in it. So maybe pi over 6, pi over 4. And the last thing is you want to make sure on your calculator the mode you're in now. If you hit the button mode, remember how before I was like, please have it in degree mode so the numbers turn out right? The mode for this is now radian mode. So let's fill out our basic sine, cosine, tangent table. The cool thing is that the values are the same because I'm still telling you to spin the same amount. So before, remember how we had 30 degrees, we had 45 degrees, and we had 60 degrees? Well, now in radians, that's pi over 6 radians, pi over 4 radians, and pi over 3 radians. Now, the way I remember which one is which, the 4 kind of goes with the 4, and the 3 and the 6 are opposite. So 3 goes with 6, and 6 goes with 3. Now, the table is the same. So asking for sine of 30 degrees is the same thing as asking what's the sine of pi over 6. Well, we already know that that's 1/2. We know the cosine of pi over 6 is the square root of 3 over 2. And we know the tangent of pi over 6 is the square root of 3 over 3. These are the same values. We just talk about the degrees differently. So sine of 45 is the same thing as sine of pi over 4. Remember, that's equal to square root of 2 over 2, which is the same as cosine. And if we take them and divide them, that's 1 for tangent. Last up, sine of pi over 3. It's the same thing as me saying sine of 60. So this is square root of 3 over 2. This is 1 over 2. And this is square root of 3. So the really cool thing about these problems, if you are awesome at this in degrees, you're going to be awesome at it in radians. So you really don't have to learn too much, just a different way of talking. So now let's talk about some properties, about coterminal angles, about sines, and about reference angles. So if we have our graph with our circle, like before I said, here we start at 0. If we rotate 90 degrees, that's actually rotating pi over 2 radians. If we rotate another 90 degrees, that's actually rotating another pi over 2, so this becomes pi. If you rotate another pi over 2, this is 3 pi over 2. And lastly, if we rotate all the way around the circle, instead of 0, it is 2 pi radians. So these are some values you want to get kind of familiar with and where they're located. Then we end up with coterminal angles. So remember how before we would add or subtract 360 degrees? 360 meant all the way around the circle. Now all the way around the circle is 2 pi. So to do this, we're going to add or subtract 2 pi. And you can do this as many times as you want, and you'll find an infinite amount of coterminal angles. So, say we have pi over 3. Well, I need to add 2 pi, or I can subtract 2 pi and I'll find another coterminal angle. However, if I have pi over 3 and I'm trying to add 2 pi, that's kind of hard because I have a fraction and I don't have a common denominator. I can get a common denominator by multiplying by 3 over 3, right? And then they'll both have a denominator of 3. So that becomes pi over 3 plus 6 pi over 2. Now remember, 6 pi over 3, yikes. Now remember, I just add the numerators, keep the denominators the same. So my new coterminal angle is 7 pi over 3. So what this looks like on a graph, pi over 3 is about 30 degrees. So here's pi over 3. If I spun pi over 3 and then spun an additional 2 pi, I'd end up at 7 pi over 3. Now another thing I can do is spin the other way. So if I start at pi over 3 and I spin all the way around the other way, so minus 2 pi, well that's really, I need to get a common denominator. That's really pi over 3 minus 6 pi over 3. Now, in front of the pi is really like a 1, so if I have 1 pi and I take away 6 pi's, I'm left with negative 5 pi's. So, this would happen, let's try this in blue now. I start at pi over 3, and I go all the way around the other way. This is also negative 5 pi over 3. Now, let's try a different example. So maybe I have something like negative 5 pi over 6. And I want to know, can you name a coterminal angle? All you got to do is either add 2 pi or subtract 2 pi. But when we do this, we want to make sure we have a common denominator. So for this first one, we take negative 5 pi over 6 and we add 2 pi. Don't have a common denominator, so I have to multiply by the denominator I want it to be. So this becomes negative 5 pi over 6 plus 12 pi over 6, which turns out to be 7 pi over 6. Or I could subtract 2 pi. But remember, I just found out that 2 pi is really 12 pi over 6, so I could say minus 5 pi over 6 minus 12 pi over 6. If I do negative 5 pi and I take away negative 12 pi's, I'm left with negative 17 pi over 6. So that's how you find your coterminal angles, just like you would with degrees, but that was adding or subtracting 360, just spinning around multiple times. Now, just like before, our reference angles, they're still going to be the distance from the x-axis. Now, the really cool thing about reference angles now is they are super easy to see without even drawing. So, say I have 7 pi over 6. The first thing I need to do is figure out where that is. I know here is pi. Well, pi, if I multiply by 6 over 6, is really 6 pi over 6. So I know I have to go a little bit more than 6 pi over 6 to get to 7 pi over 6. So here I have 7 pi over 6. Now if you ask yourself, how far away is this from the x-axis? The closest way to get to the x-axis is just pi over 6. That means the reference angle is pi over 6. Notice the denominators. Here, there was kind of that pi over 6. It's still 6. So our reference angle is really easy to spot. Let's try one more just so you get the idea of it. So let's try 15 pi over 4. Now, one thing you have to be good at is converting your fractions. So what I mean is, here's 0. Here's pi. Pi is really like 4 pi over 4. Just like 1 is really like 4 over 4. So I spun 4 pi over 4. 2 pi is really like 8 pi over 4. So now I spun 8 pi over 4. Then I got around again. Now I'm at 12 pi over 4. If I spun all the way around, I'd be at 16 pi over 4. That's too much. So I'm going to go one less than that. And I finally end up at 15 pi over 4. Well, how far away is 15 pi over 4 from the x-axis? The x-axis, the closest thing is 16 pi over 4. The distance between them is just pi over 4. So I don't want to make this sound more complicated than it really is. Remember, before we kind of didn't easily spot the reference angle. Now our reference angle is really easy to spot by looking at the denominator and at the pi on top. So if the denominator is 6 and there's a pi on top, the reference angle is pi over 6. If the denominator is 4 and there's a pi on top, the reference angle is pi over 4. So just get comfortable with using these different words for angles rather than degrees. But the math that you do is almost exactly the same.